Yeah. Hi, everyone. This is a panel about implementing robust AI methodology at all levels. And in our panel, we have, starting from the rightmost side, we have Varun Kohli, lead machine learning engineer at Google. We have Sarah Hack. She's a senior machine learning lead at Artsy. And Prokopis Gryllos, senior data scientist at Shopify. Cool. So, welcome everyone. I would like to start this panel by introducing the topic. It stems in two ways, right? We could say that methodology AI comes either from the technical perspective or from the enterprise company perspective. So, technical could be idealization, development types, evaluation, and so on. And company means how do a company behaves or interacts around the model, or how does that work in general in enterprises. So, I kick off with the first question, which says, what are your priorities when building new AI models? We could start with Varun.
Yeah, thank you so much. My name is Varun, and I'm a lead engineer working with Google Zurich. When I go ahead and look at AI systems, there are definitely tons of things that we can go ahead and prioritize when we're looking at it. But then there are definitely three of them which rings the bell, at least for me. The first one is scalability. You do not want to just go ahead and solve a problem statement, but I'm sure that everybody wants to go ahead and solve a problem statement at scale. And back at Google, when we are going around solving a problem statement at scale, it's like millions and billions, and your execution space has to be like in fractions of seconds. So scalability definitely is one of the priorities that I definitely look at. The second one is data privacy. I guess that's one of the things that I really focus on a lot when we're putting up, working along with my team, and we're putting up an architecture. We're definitely focused on a lot of data privacy measures for sure. We have I should say the machine learning industry, or by convention, we have seen a lot of security attacks on the models as well, where things can get reverse engineered, and this is like a red flag. A lot of folks, to be honest, I actually see are not focusing on it, and this is something that I really advocate a lot, that when you're building up your machine learning models, you actually have to go ahead and focus on its data privacy as well. You can actually go ahead and reverse engineer your model and get to know a lot of things that were utilized, the architecture, and a lot more other things here and there. And the third one that we usually go ahead and focuses is fairness. I remember we were chit-chatting about this thing in lunch as well. There's with fairness, I mean building up a machine learning model or an AI system which is following the morale. It is still not losing that, and I'm talking around being agnostic of a problem statement, and nothing a specific problem statement that I'm talking about. But if I pick up an example, there's a lot of people who actually come up and open up their chatbots, just for an example, in the outside world, and they want to let it learn from the world itself with the conversation, and that's a brilliant idea. But the question is, it can lead to a lot of bias and lose morale there, right? Because people would just play around with it, and that is exactly what we have seen in the previous chatbots as well happening around. And it's like garbage in and garbage out thing that comes up and happening. So this is one of the examples that I have there. But then I can definitely keep talking about tons and tons of examples. But these are the three things that we definitely focus back at Google: the scalability, making sure the data is the data privacy is measured across when you're implementing an entire platform, and the third one is fairness.
Nice. Makes sense. When you have a scalable system and you need to serve billions of people, you need to have scalability. MLOps should be there. Fairness, the purpose should be there. So then, Sarah, let's get out of the scale and go to the startup world. What are the priorities there? I suspect the technical part of the MLOps is not that kind of heavy.
Yeah, so I work for a company called Artsy. Artsy is a marketplace for selling art, and I am one of the few machine learning engineers at Artsy, so my priorities are completely different. Firstly, I am one of the few people that actually understands machine learning and how to use machine learning in a company that is full of very, very talented engineers, but this knowledge is missing. My other priority is usually product-driven. What do the users need to see? In my case, collectors, what do they need to see? Does machine learning make sense or not? So it's slightly different what I'm trying to solve. A lot of my work is around recommendations. I also have my presentation tomorrow. I don't want to say too much, but usually, for example, we built this taste profile at work. We build this taste profile, but what's missing is people not understanding what is the purpose of this taste profile? What information do we need to collect to then be able to use machine learning models? So my role is a little bit different. I'm architecting how we can use AI as opposed to how to take it next to MLOps level 1 and 2. So for me, my priorities are, well, what does the user need, and how can we harness machine learning to make sure users get what they want?
Cool. Yeah, makes sense. When you have a new organization, you need to be in a maturity level so people can use and understand what is going on with machine learning, which makes sense. Cool. And so then we have Prokopis, which is kind of the middle, I suspect.
Yeah, like, no.
Shopify or...
I guess Shopify is a big organization, but I think more companies are like Artsy than Google. Like, in that sense, Google is one of the very few companies with that many data and that many use cases. So I'm a data scientist in Shopify, and I work mostly in modeling profitability data. So our solutions serve internal stakeholders the most. And my priorities are tuned to that, but I think they're generalizable as well. My top priorities is getting stakeholder alignment, pretty much because in every machine learning use case, you have a bunch of people who think that they will achieve different things through the same model, because forecasting gross profit is one thing that could be applied to 1,000 places, but it's all about how you do it that fits to a certain use case. So stakeholder alignment is the top thing. And then really what Sarah said, testing, thinking in the product way and testing hypotheses in the most product-driven way and in the most lightweight way. Because at the end of the day, your success as a machine learning practitioner depends on doing many iterations and tuning to a certain use case, and you need to cut out all the irrelevant stuff. And the ratio of relevant to irrelevant stuff is extremely skewed. Very few things are relevant for what you're doing, and many things are irrelevant.
True. So in essence, the best approach is to kind of go in a test-driven mode, right? Like you throw away like hypothesis, you test, then you continue or something like that.
And narrow the scope, because you cannot solve everything through a single model.
Which, yeah, what I'm driving at is to the next question, which is like, what are the solutions that are proven effective in currently what you're working and on these challenges that you just mentioned? So let's go like reverse.
I can take this one now because I think I'm going to give the most basic solution.
You got the time, go.
So like the question about like what methods work, I think I'm going to say something that will not surprise everyone. It starts with the word linear. So yeah, linear regression and logistic regression, the two most basic models are the best usually, especially when you're modeling like not things that depend so much on pattern matching, like chatbots and deep learning stuff. When you're trying to model simple economics, more or less, like a simple linear model, will get you 80% of the way, and you will not. You will build opacity in the model by default, which is something that at least in our segment, in like informing internal stakeholders about profitability of each customer, it's extremely important. And there is value to actually understanding what are those predictive features that are used in the model. This actually educates stakeholders. So yeah, start with the linear models, and that's my go-to. And they usually beat most naive solutions, and they usually also beat non-linear models without much effort.
Okay, cool, good to know. At least it creates a baseline if you want to go complex.
Yeah.
Sarah.
I was itching to say.
Come on.
It's my favorite topic to talk about. Completely agree. Start simple. I work in the field of recommendations. There's lots of different machine learning, artificial intelligence algorithms that you can use. it ranges from matrix factorization all the way to these advanced sequential models. I start with matrix factorization so I can build a culture around, well, what am I trying to predict? It's easy for me to explain. People would actually default to using rule-based, and I'm trying to avoid that as much as possible. So I think it's very important to start simple. I completely agree with that. Something that I don't see adopted widely in industry is the methodology or the practice of agile data science. So we work in these sprint cultures, well, a lot of tech companies work in sprint cultures, and every 2 weeks you have tickets to deliver. This doesn't quite work for data science and machine learning, but there is this practice called agile data science. And what this, in a nutshell, does is within sort of sprint culture, you're providing deliverables. So you have this pyramid of deliverables you can find. A lot of times, these machine learning projects will fail just because it wasn't scoped out correctly, or I like the nod, it wasn't scoped out correctly, or the right data wasn't available, or there was misalignment among stakeholders. Applying agile data science methodologies means you get feedback quickly. It also gives the practitioner a bit of freedom about what algorithms like to use. If somebody wants to use a more advanced algorithm just because they're more comfortable with that, it's their personal interest, you give them a time box research phase. You say, hey, take 2 weeks, go for it. It's also, that's what I love about my field, is the freedom that I have, the freedom that I can model the data, the freedom I have to use different machine learning algorithms, and the countless domain challenges that are out there. So I would like to see more agile data science methodologies applied, and that's something that I use in my team of one. I use myself, and this way I can give stakeholders feedback regularly, and then I can keep iterating on that. And that's also why I've had a lot of success in my current role and been able to have a lot of impact with, I repeat, a team of one. But yeah, super curious to hear what Google has to say about all of this.
So then, to Varun, yeah, so you mentioned the scalability, MLOps problems. Is there any, what is, the solutions, or what do you see on, at least on your current projects or from your experience?
Yeah, so at least from my experience, I definitely, so I'll try covering all of the 3 points that I actually picked up, but I definitely think that if I talk about scalability, starting simple is the one to go. But along with that, what we usually go ahead and try to think around is having a neat architecture. When you're looking at a problem statement, you can go ahead and create multiple architectures, go into multiple iterations. The AI world is like that you hit and try, create more architectures here and there, and then you probably land onto one of the things that you think this is the right one that solves my problem statement at scale, at good precision, and all those kind of things. So start with a very clear architecture. That's something that I really advocate. Has to be robust enough. Because we're looking at the architecture in terms of the scalability perspective. That is the bullseye. That's something that we're definitely focusing on. So a very, very strong and a robust and a neat architecture that helps you around. When I talk about architecture, there's a lot more things that we go ahead and play around with. In other words, your model has to be cost effective, right? And at the same time, it's not just in terms of the deployment side, but you also have to kind of go ahead and focus in terms of the training side as well. So if I deep dive on it, you would want to probably, the things that we go ahead and try to follow up is use your processors, which is really nicely compiled or work really well with your machine learning libraries. For example, what we usually try to prefer use is using TensorFlow along with TPUs. That is cost efficient as well. To define TPUs, these are this question has been coming towards myself multiple times, but I'm sure everybody has a different answer to it. The simplest answer that I think that I can actually go ahead and try to explain something is that you can assume TPUs to be ASIC machines which are actually built just for TensorFlows. Ideally, this is not the actual one, but this is exactly what they are doing. TPUs were created so that they could run TensorFlow algorithms in the most optimized way. So when there is something that this kind of thing exists, why not utilize it? Plus, it is cost effective as well in comparison to using other libraries along with probably GPUs and tons of GPUs and configurations of GPUs. So yeah, so when I talk about architecture, these are all the things that I actually focus on from implementation perspectives and from the scalability perspectives and all those kind of things. From data privacy, I guess I've just been advocating a lot on having splitting the problem statement into 3 different specific teams, you definitely start with a research team. That is a core team that goes ahead and builds an algorithm, researches around it, and then decides on the architecture and everything. You have a machine learning engineering team that goes ahead and deploys the entire system for you, but then you don't leave it right there. You have a ML ops team, which is something most of the like setups, I believe, are actually not having right now. And here is where that is going to go ahead and help you in identifying the data privacy leaks or the reverse engineered setups that can actually happen on your algorithm. So you got to have that thing. Or rather, in other words, you can't, like, now I'm leading to the third point, which is fairness. You can't open up your model. I know the models are data hungry, but you can't open it up for the world to go ahead and get, and rather learn your model on outside world based on the chatbots and everything. So make sure that you strategize well, put those strategies in place that make sure that your model is not going to lose that morale. And those going to be like different perspectives here and there. It's going to be very enterprise driven, but few simple concepts would be obviously not, like, if I would have never, I know like the model would have been a lot data hungry, but I would have still not ventured out in opening up my chatbot to the outside world and like make sure to learn things. Even if I would have done that, I would have scrutinized and like tighten up a lot of keywords here and there just to make sure that it doesn't even like get into my model, because you know that it's like, it's an online training platform what we're talking about. So yeah, those are my points.
Cool. So to summarize, I think from Prokopis is to start simple and build from that. Then we also have to go agile, as Sarah mentioned, making this more dynamic. And then if you want to scale this to million users and billions of users, then you have to think about committing an architecture, committing people to ML ops, and also testing rigorously, not misuse, abuse, and compliance, you know, if that product is going to go to the people and to the world.
Absolutely.
And what's funny is that probably both me and Sarah were inspired by the Google ML guide that was released like 5-6 years ago or more. So we are preaching what this guide was saying.
Well, it's not only you, so it's good.
Also, just to add, hearing you, I feel like every company thinks that's what we're trying to solve, whereas actually very few companies are trying to, I mean, it's just the FANGs and maybe a handful of other companies are at that stage. I really think we have to start from the basics, and that's why that's actually something that I'm trying to share more of right now. AI is this huge term, and it has so much power, and we just haven't even, companies haven't even touched the surface. But
I wouldn't underestimate the power of the smaller companies. It's always nice to kind of be in a way against Google, Amazon. The things that they build is massive. But in essence, they might miss the simple stuff that when they were small, they solved. So now it's turn of the smaller companies to solve a lot of things that maybe bigger companies cannot see anymore.
Sorry, just to clarify, what I meant was when people are solving, let's say ML ops, they go straight to ML ops level 2, which is what these large-scale companies are at. I just mean it's an iterative approach. Yeah. So companies need to start with their baseline ML infrastructure in place and then build on that. But I feel like we jumped that. I enjoy my work. Yeah, okay. I also enjoy working small companies. Sorry, that's what I meant. We just go straight to ML ops.
Right.
FANG as opposed to working iteratively. But
cool. So then, with this, goes to the next question. It says, like, what is the biggest mistake people make when building an AI system? So, Sarah, since you started going into the direction of jumping into levels.
Just read your mind. Yeah, I think that's all. I guess just to reiterate what I mentioned, I think a lot of companies, because we are so influenced by these tech giants, we feel like we're trying to solve a completely different problem. So I feel companies are not quite sure what they're trying to solve, and they're not aware of how they can use machine learning, AI algorithms to their best, and they don't know how to build the infrastructure around it. And also, people are treating machine learning engineering separate, or they're keeping it separate from software engineering. There's a lot of software engineering principles that people can apply when deploying these models, and there seems to be a disconnect with that. So that's something that I see happening a lot. putting the machine learning models in production, mainly a slightly different infrastructure, but the way it's being served, that's something companies have been doing for a long time. So the fact that there's this huge disconnect between traditional software engineering and machine learning engineering, that's, I feel, a little something that I see in industry right now.
So in essence, to summarize, is, as far as I understand, is we jump actually, we think that we can solve something, we go more complex than we're supposed to. And then we also detach ourselves from the software engineering, which basically at some point machine learning is software engineering, right?
Maybe I can compliment also on what Sarah says, because it really works with what I'm thinking. First of all, I don't think people make big mistakes. I think organizations make big mistakes. Like, if people end up making a huge mistake, that's due to the organization having wrong processes.
I'll change the question. Mistake people.
So, like, I think the biggest, hurdle to like organization deploying AI effectively is really the thing that also solves what Sarah said, is having the thought leadership that understands how AI should work. Because at the end of the day, all those questions, like, is it machine learning engineering, is it software engineering, is it data engineering, and where do data scientists fall? At the end of the day, this may work differently for each company, or it may take a unique flavor for each company. And it's the thought leadership that really needs to understand how AI should work in this company end to end, from high-level decision-making all the way down to implementation. And I've seen that in companies where you don't have that, you may have ICs or like mid-managers that understand AI, that want to enable people to do AI, but if you don't get the right resources, the right tools, and the decision to invest in people and tools for AI, you will constantly keep hitting a wall. And yeah, that's where the biggest mistakes can come from. Also, you want to establish the right processes to properly test and release your AI. And we've seen plenty of big mistakes happening in the past year. I don't want to be too specific here.
So to sort of understand is basically AI culture within the company, right? The leadership should invest in this and should hire the proper people to manage this, like to base how the deployment should be in technical terms, how the idealization should be, and what is the test cases.
Yeah, the leaders should really nurture a data-centric mentality.
Yeah. And how this could be specific in any company for whatever case.
Exactly. Find how this would work in your company.
Cool. And Varun, to your experience, well, not the biggest, but at least in the terms of scaling or let's say the biggest corporates, do you see any common or mistakes that people make?
I guess the common mistake, I shouldn't call it a mistake, but then a common trend that
misalignment or misdirection.
I guess I called it out, and I would like plus one to that is actually not having an MLOps team. Something like we usually go about it like a trend where we go ahead and build a next grade AI system that is evolved. We go ahead and deploy it as well, which is running at like an amazing scale, serving to like millions and billions of users at like fraction of minutes of seconds. That is also very amazing. But the focus is just on the last part, where we want to go ahead and make sure that this is not misused, and for that, not having an MLOps team. So like this is something that I'm seeing that probably is getting missed again and again. So having an MLOps team, as I said, is going to help you in a lot more efforts. One is, we just spoke about was data privacy. It's just going to make sure that those measures are kept in place. The other thing that I also see a lot coming out of is definitely saving your systems from getting reverse engineered. For an example, let's say if you have a model which is probably predicting something outright, maybe just like a basic CNN model, you could go ahead and start looking at that by randomly giving certain set of images here and there is a certain user who's trying to go ahead and reverse engineer something out of it. He's randomly giving, so probably it's fishy enough for one specific user to go ahead and literally use it probably a lot than that he should be utilizing it, and with some random similar images, right? So this is exactly that MLOps team is going to do. You can actually have like a sub part of it that focuses on these kind of things to make sure you're identifying those kind of probably users or misusers who are trying to go ahead and identify loopholes into your system. The moment that gets exploded, and I'm talking about like a product-centric thing, right? You probably have a breach in your model, which is something I'm sure like a standard AI system would not expect to have. So yeah, I'd again say like having an MLOps team probably now in a system which is like we were just speaking about in the last presentation where we were like in the final slide, we were looking at the third wave of AI. We are actually in the third wave of AI, and we're soon getting into like further into the fourth, which is neuromorphic cognitive models, which are not far. We already have chipsets being developed, soon going towards quantum AI. Again, not very far. Systems are already there in place. We're just getting started with it. That is the fourth wave that we're actually looking at it. But then before even we jump onto that, we have to make sure that, that the models or the systems that we're building are robust enough. And this specific team, that it's just going to go ahead and advocate and then make sure that we have the right set of infrastructure and the right set of teams in place.
MLOps everywhere.
Yep.
It has to be there. That's what I understand. Cool. So I think we have time for one more question, or unless there's questions now from the audience. If not, okay. I do have another question for you.
There's a question in the audience as well.
Sorry. Yeah.
You mentioned a lot prevent reverse engineering, but it's always trade-off between how much time you put on the security and how much time you can spend on development. How you solve this issue, how you find balance, and what is the cheapest option to prevent reverse engineering in case of ML AI tasks?
Yeah, so if I quickly answer this question, you would have a separate team for this. Like the development, so like every model that we're actually building, it is not gonna run for life. So for that, you have the machine learning engineering team that can probably pick it up, or maybe if you still have the research engineering team, which probably might have not jumped onto the next problem statement, if they still exist, they are the ones who focus on the life of the model, right? But at the same time, so here you introduce a separate team that still sticks around, no matter the machine learning engineers and the researchers have probably now picked up the next problem statement. These are the ones who still stick around and try to keep focusing on looking at the life of the model, looking at whether, like what kind of precision, like is it still meeting the same precision? Because there'll be like newer trends, no matter what problem statement that we talk about. Maybe translate, right? There would be new slangs that would just get introduced probably in the German language itself. I'm sorry, I do not understand German, but yeah. In the German language itself, you would probably go ahead and introduce more slangs in it that you would definitely might want your model also to go ahead and translate, right? That's expected something out of it. And this is the team that would probably see, oh, my precision is dropping. And this is where I probably go ahead and introduce, I would rather ask the other team to pitch in. And this is one of these efforts. The other effort would definitely be focusing on identifying, is anybody trying to reverse engineer or trying to utilize the APIs that I have granted to, let's say the translate API that I have granted to the users in a very different fishy way, or maybe utilizing it to some other random way?
Is it maybe it's easier to get watermarks instead of trying prevent reverse engineer? Do you try to use this option?
So that,
for example, I have quite a simple example. We developed ISR-TTS models, and we had a long discussion about how much time we need to spend on security and everything else. And we discussed that lifetime value of our product is half of the year, so it's not so important because we totally change this model every half of the year. Second thought, so if somebody will steal it, okay, we just add watermarks, and if it will happen, we will just come with lawyers and ask them to pay money. That's it. Do you try the same thing?
Absolutely. I like the answer that I have for this problem statement is that it's very relatable to the organization or very relatable to the problem statement that you're solving. Let's say the watermark could be a good example for images, but let's say not for text, right? So there has to be like a different methodology or like a different strategy that has to be kept in place. And I'm sure if we deep dive into strategies, I might eat away their time as well. Yeah, but then there are like different varieties of strategies that you can follow. But what we're talking about, this agenda, that this is something that should probably done before we even jump onto the fourth wave, which is right there.
We have a team that makes produce practices, but they are not coding something. Do you have the same thing, or you have coders that check the code or add code to the product?
So if I understand the question correctly, and
the dedicated team, they only produce practices which developers should follow, but they do not develop something or code something. They just set the rules what developers should follow. Or you have dedicated team that developers of coders.
So that again, I guess, depends on an organization how they are structuring their MLOps team. If they are empowering them to go ahead and probably take up some of the engineering effort as well, then they can definitely go ahead and code. But I'd say it depends on how a company's leadership is looking at and empowering an MLOps team in defining their scope. Right. So a scope would be very different. But a quick answer, at least on like splitting up the security, I actually want to make it clear that there are two different security aspects that we're talking about. One is an AI system security. In other words, what we're looking at, just like it could be a random product as well. It's security. But what I'm also focusing on is this team, the MLOps team would actually go ahead and start looking at the security of the specific model. So in other words, start imagining that you have like a web UI in front of you, and that's a website, right? So people, I just demonstrated intruding today in the morning. That probably is a security aspect on the software engineering part, the website that you're looking at, right? But that after logging into that, you have probably like a translate or maybe like or it could be like a facial recognition engine or whichever that you're putting up an image and then it's able to scan out something. We're talking about this MLOps team focusing on not making sure that particular feature set is also not getting misused, which is not going to fall into the software engineering security part. Like it's not intruding, it's intruding into the machine learning model, getting reverse engineered. And there is where you can actually have data privacy issues.